main programming languages. I call every programming language. But effectively, kind of the important programming language was C. That was one of the first important compiled language. In 78, you have SQL. Now, we're still going to be talking about and using SQL today. And one of the important things that have happened since 92, C went from procedural to object-based in 1980. So you have C++ and C#, okay, which is Microsoft. Right? So today, the languages that you're probably familiar with, that we'll be dealing with, is Python, Java. You're familiar with Java. We're not going to be teaching Java, okay? But we'll be dealing with Python. We will touch a little bit on PHP, and we're going to work on SQL. Okay, I want to make one point. In terms of programming, like most of you are researchers, we work in ministries, agencies, you don't program every day. One of the problems with programming is there is a very big learning curve in the beginning. You become a good programmer only if you keep programming, right? If you stop programming, you forget like me, and then the next time I have to write a program, it takes me 2 or 3 days to get back my brain into action and start programming again. So programming is good to learn. Use it in your job, and the more you use it, the better you will be. But if you use it on and off, you'll have to start again. But it's easier, but you still have to restart. So then I'm going to talk a little bit about database applications. So we're relating to some programming we're going to do. We have to understand databases, because that's really the data information we have to deal with. All the information we're using today on your smartphones and on your computers comes from a database. So we need to understand databases. Okay, so let's go through history again. So back in 79, when the first personal computers came out, the first kind of useful programming application was VisiCalc. So VisiCalc is like a very early version of Excel. It's a spreadsheet. And early on, people like IBM developed DB2, and Oracle, Sybase, and Formix in around 83. Those were really for the big computers, the mainframes and the minis. So you can notice that the evolution around 85, when you had the IBM PC, you start to have Excel, Microsoft SQL Server, Microsoft Access. Those were all starting to be available for the personal computer. So at around 95, Oracle was ported to the PC. Then you have open source programs. These are what I call enterprise databases. These are databases that scale to a big organization, okay? Like your Ministry of Environment, Ministry of Mines will be using these kind of databases. These are enterprise databases. Okay, and then in around 2000, you have basically OpenOffice, which is open source Office that competed with Microsoft Office. For background, I do not use Microsoft Office myself. I use LibreOffice. So LibreOffice is also, it's what we call a branch of OpenOffice, but it's open source. I have not used any Microsoft Office products for maybe the last 8 years. So it's something you can adopt if you wish. I only use Microsoft Office products when I have to use it for an application. This is just to give you an idea, because we have so many languages. You can say, well, what should I learn? What do I need? So just give you an idea, we're really dealing with Python. Okay, so Python is within the top 5 of all the columns that has been surveyed by ZDNet. So really, Python's here, PHP is up here, within the top group. So we'll be dealing with Python, PHP. I think the idea is, there's a lot of programming languages people use, but I think in the top 3 right today, Python is within the top 3 of what programmers use today. So when we're talking about what we're trying to teach you now is we're looking at the internet world, the World Wide Web, and we're looking at data and information as being one of the primary components of the web world. Okay, so we have basically the back end is the database, okay, and that's the key information source. So everything you do on your computer, your phone, your tablet comes from a database. And that is another term you'll hear Linda and myself talking about. We call that the back end. So the database is the back end of the system. And so your browser would be your front end. And then in between, you have some software programming. I just briefly want to say that in doing projects, when you do a database design, there are a number of components you need to think about. This is what I call a database application lifecycle. Now, this is a model normally used for relational databases, RDBMS. What I'd like to say is that, when you design something like a database, you really need to do what we call situation analysis, and then you do the database design. First, you have to say, what am I creating the database for? So once you know what you're developing the database for, then there is basically the database design, which is 3 steps. So there's the conceptual design, the logical design, and then the physical design. Unfortunately, 80% of databases start at the wrong place, the physical design. And that creates a lot of problems for the software later on. And then you have administration, which is implementation, data loading, testing, operation and maintenance, okay? Data loading and conversion. This means you're encoding or you're doing data entry from paper to digital. So this is a life cycle. This is one model you can follow for simple relational database design. When we look at our world and we're trying to design applications, you'll hear the words modeling, okay? So today we look at system modeling. Everything we do relates to systems. So basic components of a system is input, process, output. So some of the outputs include raw data, information would be reports, graphics, and so on. So when we look at system modeling, some of the key things you need to ask is who, what, when, how. So if we take, this is the example, and we apply it, okay? So if you want to do an appointment system, your input would be who, when, where, how is a secretary. She is taking phone call appointments located in an office. Where is the office? How is to book it into the computer. So the process would be the appointment book or computer. And then the outputs would be, if you look at your appointment book, you can find out who, where, how, and when in terms of appointments. Now we come to something more complicated, all right? So in terms of modeling and database kind of design, I'm going to cover the Zachman framework. Zachman framework is an enterprise ontology and is a fundamental structure for enterprise architecture, which provides a formal and structured way of viewing and defining an enterprise. Ontology is it's a complicated word meaning entity and relations. It's connecting, okay? It's basically a schema. So ontology means within an enterprise, you have, let's say, objects or items that are connected. So ontology is the process of joining pieces inside an organization. Zachman is actually a computer scientist or engineer, worked for IBM, and he was the one that came up with this framework for big enterprise design. And you don't have to use this for computer design. This could be used for organizational design as well. So, for example, each column contains, for example, the first column is scope or role. The top line, top level, okay? So this is the top of your organization. And then the second is the business. The third is the information architecture or modeler. The fourth is the technology designer. This is the builder. And the sixth, the functional, what they call functional system. These are different levels of hierarchy. And the programmer is down here. And then basically the what is data. This column talks about data at each level. This column is the function or how. And the middle column is the network or where. And this column is the people or who. This is the time column or when. And the last column is what they call motivation or why. So we'll just go into it a little bit because I think this is useful when you look at the big system. This is another way of looking at the Zachman framework. So rule 1, columns have no order. Each column is a simple basic model. The basic model of each column is unique. Rule 3. Rule 4, each row represents a distinct view. Rule 5, each cell is unique. And Rule 6, combining the cells in a row forms a complete description of that view. So, example, remember I said the life cycle of the database design. I had discussion of conceptual, logical, physical. So you took that flowchart of mine. Okay, so I talked about situation analysis, which is the context, the first row on that Zachman framework. First row of the Zachman framework, second, third, and fourth row, and then he had a couple that kind of combines the administration side of things. So you take the framework and we use some different words. This is for the American Coast Guard enterprise design. Breaks it down into planner's view, the first column. The contextual is planning, right? Situation analysis. Then you have basically the conceptual is the owner's view. The logical design is the designer's view. Physical is the builder's view. And the subcontractor is really the programmers. So our training will be somewhere down here, but you need to understand all this part as well. So this gives you another view of the chart. If you see the background, the blue, the light blue, so this part of the framework relates to operational view, operations. And systems view, brown, this is the systems. Things like system interface, etc. And then what they say is technical view, rules are not explicit in the diagram, so there's more details that is not covered by the diagram. In the US, the federal government has an architectural framework. They use the Zachman framework. So I'll just point out some principles. By using this framework, they're trying to use the framework so that they can organize government information at a wide scale. And then the second point is they want to promote information sharing between the federal agencies. And then it would help each organization develop the architecture for their database. They feel that if you follow this matrix, it would develop the IT investment quickly. So the bottom is that you want to serve customers better, faster, more cost effectively. I'm going to go out and I'm going to run the Zachman tutorial. So I'll quickly run through this tutorial, which is a more graphic description of the Zachman framework. So this is the framework in your enterprise. This is an example of the Zachman framework. So down here is the functioning enterprise. We have the planner, the owner, the designer, the builder, subcontractor, and that's your output. So up here you have the conceptual model, which is the owner will be involved in. Logical model, the designer. Physical model, the builder. The detailed, which is the subcontractor, or really the programming team, would be involved here. So Zachman framework. So the scope, you design the scope. So business process models is the second step here. And then the logical models is requirements. And the fourth is the technology model, the physical model, the solution. And the fifth is the as-built, so the completed application. And the last is the functioning enterprise. So to give you an idea of this, for example, I'm working on another project in Colombia. And in the project, the Canadian government is funding a $3 million integrated mining management system. So with the Colombian government, we've gone through business process models. We've looked at the logical models, requirements of their system. And then we've looked at the physical models. And then the as-built is really a commercial off-the-shelf software that is going to be customized. So, framework rules, let's look at that. Columns have no order. Second, each column has a simple basic model. For example, entity relationship model. And rule 3, basic models of each column is unique. And rule 4, each row represents a distinct view. 5th, each cell is unique. And 6, combining cells in one row completes the description of that view. Planner's view. So for the planner, you need to look at the external requirements and drivers. You look at business functioning model. So the business process, motivation, why, business goals, objectives, performance measures related to each function. The how, high-level business functions, how does it work? Okay, then the data, high-level data classes related to each function. And then the who, so the stakeholders related to each function. So who are the people? So the network would be where, okay? Where are the locations related to each function? And then finally, when, time, is cycles and events related to each function. So the enterprise, the model, designer's view, the analysts. So if you're involved in large IT type projects, you will hear this word business process models, and then business function allocation, elimination of function overlap and ambiguity. Why? Policies, procedures, standards for each process. Okay? Functioning, the business processes, how, what business data is required. Who are the people involved, responsible for each process? And where are they located? And when are these processes required? Okay, so the system modeler design, logical, project management, requirement definition, standards, procedures associated with a business rule model, logical representation of information systems and the relationships, logical data models and data relationships, logical represented privileges, access, so this is back to security, and then where? They're located in the architecture, system architecture, and when. It's a fine line between conceptual and logical, sometimes the same people. So this one here is distinct. This is physical models, so this is actually applying a database to the design earlier. So at this level, you have picked a database. For example, it could be MySQL, it could be Oracle. So now, at the physical level, there are some constraints by what Oracle will or will not allow you to do. And so this again is platform related. Okay, so it's what computers you use and what database you're using. So in this case, for example, database management is constrained by the logical data models. We'll go to the integrator view. I'll just scroll through this very quickly. Once you have finished all that exercise, build the system on the database, have your computers working, and this is the user's view. And that is your framework portal, and that's it. So we actually ran the Zachman tutorial, so we'll move on to a bit of modeling. So in today's world, where we're doing web-based database applications, you will hear this term UML, Unified Modeling Language, which is used for modeling relational databases, but with a twist of object-oriented. Just now, earlier before the break, we were talking about the Zachman framework. So the Zachman framework is actually an enterprise architecture framework that you use to define, manage your enterprise database. Now we're getting into actually the functional components, design components, physical design components. So today we use UML. In the past, we use entity relation diagrams. So the entity relation model is what they call implemented as a database. It's a simple relational database implementation where you have an entity, which is a row of a table, is an entity, and you link the entities together into a relational database. So you use what we call ER diagramming, and the conceptual logical model, that stage to build a physical model. This, just to show you a diagram, this is a typical ER diagram. So this would be a model, the link diagram. With the evolution, as I said earlier, programming went from procedural to object-oriented. In a similar way, the database modeling also went from procedural with the entity relation diagrams to the UML, which is object-oriented. So there are a lot of advantages to using object-oriented programming. It allows you to build bigger, complex systems with less problems when you have to change. So it's what we call object relational databases using object-oriented programming like Python, Perl, Java. So in the UML diagram, each object is defined by what we call class, and then abstractions of the class. It has abstraction, encapsulation, inheritance, and polymorphism. Anyway, these are complicated terms that we will not be able to translate. But if you want to get deeper into object-oriented programming, which I needed Linda here to explain, but she's having a virus on the sticks, so we're on her computer, which she's trying to fix right now. So for our object relational databases and the UML coding, we have basically object classes for each object has a class, and we will go into that. Unified Modeling Language, UML has a class diagram, component, composite structure. So these are all diagrams under the UML. So this is called a static view. And then you have behavioral diagrams, which is dynamic. You can have activity, communication, interaction, sequence, state, timing, and use case diagrams, which is dynamic. We'll see an example of an object class when we get into the UML. So UML2, currently version 2 of the UML is the standard, and this would be typical of structure of the UML2 classification. We won't be dealing with all these. I mean, this is quite advanced. If you are into object-oriented database design and programming, then you get into more detail. For us, we're going to just take the surface. The UML is a way to visualize system architecture. So it can plot activities, individual components of the system, how they interact with software, how the system will run, how entities interact with others, and the user interface. So if your enterprise or your organization is designing a sophisticated enterprise database, part of the documentation you will get would be business process modeling document in the manual from the developer with all the diagrams that we mentioned up here. So if you go back to the Zachman framework, from that, it's one of those hierarchies, you would come up with a process for your organization. From this, you would actually extract the database model that you will be using to accomplish the needs of your organization. So this is what it says. Although originally intended for object-oriented design documentation, UML has been extended to a larger set of design documentation, and it's useful in many contexts. So just to recap, entity relationship is one of the methodologies for designing a relational database. So back in '76, this is still used, but it's being replaced by UML now, which is designed later when we had more object-oriented type programming happening. So now it's been used for programming, design of programming for object-oriented. So moving along, digital database. So back to our database. So a database, digital, is a collection of data organized so that a computer program can quickly select pieces of information or data from the program. So database consists of fields, records, and files. So in a simple database or table can be considered an Excel spreadsheet can be considered a table or simple database, or also known as a platform. So a database management system is a collection of programs that enables you to enter, organize, and select data in the database. And a relational database, or RDBMS, is a system that stores data in related tables, so linked tables are linked. So a relational database is a database, but it has many tables that are connected. Okay, so this is just a kind of idea of a relational database structure. So you have the memory of data, tables, rows, columns, indexes. You have processes, logging, reading, and then this is all part of a server. This is the physical storage model in the database. Okay, so you have a physical and a memory. So the hard disk stores the data, and you need to load your program into memory, and the memory manages the data. So let's talk a little bit about relational database applications. So we've all heard of Oracle, and we've all heard of MySQL, but there's a newer version now, another fork of MySQL called MariaDB. It's the same as MySQL. Then of course we have Microsoft SQL Server, PostgreSQL, IBM DB2, Microsoft Access, and SQLite. So the open source databases are MariaDB, PostgreSQL. Okay, so these are the most widely used open source databases. Amazon, Google, those people mainly use open source. In North America, government tends to use Oracle. In Europe, what's happening now in Europe is a lot of the government, people like UN, are switching to open source. So out of these, basically, Oracle, PostgreSQL, DB2 support object relational database management, which is also called ORDBMS. All right, then I'll briefly talk about Agile. This is really a methodology of software development. So when you, as an organization, hires an IT company, if the IT company tells you they use Agile approach to their software development, Agile is a process where they try to do what they call projects that break down into product backlog. They break the programming into pieces, for the terminology now, which allows the project team to rapidly develop and test modules. And each programming team can give you an estimate of how much time they're going to. And then you can take these and you determine whether they'll take a longer time in days or they take it in 1 day in hours. And use the term called sprint, scrum. A scrum is just a group of people getting together. Usually in American football, in rugby, it's a scrum. So I would suggest, this is not something we're going to teach you to do, but we'll mention this. These are technologies, I would say that when I deal with IT companies on enterprise database design, we will be talking this terminology. So anyway, this is just a technique, and if you work together or have a group that want to develop a sophisticated program, you can look at this as a methodology to apply to a bunch of programs. In your USB stick, we will give you some of this information. We do this tutorial of design and have some links here for you to check out a little bit more about LibreOffice.